Welcome. So this is on extending the lightweight render pipeline. I've got to warn you, I've broken all the rules of good slide design. There's lots of code in this presentation. So hopefully that's for you. That might be a good thing, it might be a bad thing, who knows, but we're extending the lightweight render pipeline, so it's going to involve writing code. So if you've used the frame debugger before, that will help you as well. If you haven't done either of those things, you'll still get an idea about what it means to extend the pipeline and why you should do it as well. So my name's John. I work for Unity in Australia. Let's talk about the lightweight render pipeline. Just a quick overview. Considering you're in this room, I assume you know what it is. It's our new scriptable render pipeline. It's aimed at virtual reality and mobile. It's very efficient, and it's very simple, which is why I really like it, because when we're customizing and extending it, it's got a very simple model to work with. We know it's a forward renderer, and we know when things happen and what's available to us. So why would you want to extend or customize it? Well, because it's simple, there's some features that it doesn't have. So for instance, the grab pass, which lets you grab a copy of the screen and then do some distortion effects, is missing. It's not there. So I'll show you an example today on how to implement that. So if you want to implement a special effect, or there's a missing feature, then that's when you'll start to go, how do I extend or customize this? I'll show you later on as well, you can actually replace all the existing render stages as well with your own. So if you're thinking about doing an extremely custom renderer, you might want to start with a lightweight render pipeline and just replace it completely. So if you want to have a hybrid pipeline. So this is just a demo of showing some of the techniques. All the pixel effects of the video, not the sample. This is called Boat Attack. You can download this. It's a project you can pull apart and have a look at how it's structured. It's been customized as well. So there's the reflections on the water, and you can see the nice the sea floor here. That's been added as a custom effect here. And the examples I'll show today will show you an approach that you can use for that. But you can still see, even on mobile, even on this lightweight render pipeline, we can still get some nice visuals with lots of efficiency. So what we're going to be doing, what we're concentrating on here is a render pass. We're going to be making render passes and changing render passes. So what is a render pass? What does that mean? It really means a series of graphics commands, a series of draw calls that go to a particular render target. So this might mean that you want to use a certain shader to render your scene. You want to draw certain objects. You want to copy one texture to another texture and do some blurring. These are the sorts of things you'd do in a render pass. We're going to create a custom render pass, but what that really is just a callback. You can do whatever you want in your render pass. You could synchronize frames for a renderer that has multiple displays. You could do your own graphics effect. You could launch a rocket, whatever you'd like. It's just some code there that's available to you to inject something into the render pipeline at a certain stage. So this is the frame debugger. It's a screenshot of the frame debugger. And this is just a simple scene with one opaque object in the scene. And so these are the render passes that are in there by default that the lightweight render pipeline puts in. Shadow rendering, depth rendering, rendered opaque objects, skybox, etc. And what we want to do is we want to insert some stuff into here to do our own custom effects. So let's look at that. Let's look at how we're going to make our custom effect. So the first line of code, I warned you that this is all we have to do is inherit from scriptable render pass class and implement this execute method. I should mention all these examples I'm going to show you today. I'm going to show you 2 examples. They're available in the GitHub repository, and I'm going to give you a link at the end. So you can download these projects. So you don't have to, the idea here is not to memorize code and memorize the API. It's really about just getting the general principles about how you would do this yourself. And then you can look at the code yourself later on if need be. So we're overriding scriptable render pass, and then there's a function called execute. This is pretty straightforward. We get some data about what we're rendering, how the camera's been set up, etc. And then I've also added some really common boilerplate code in here. Because we're doing graphics commands, often we're going to use the command buffer class. This is something that lets you do queue up a whole bunch of graphics commands like blitting, etc. So first thing we do is get a command buffer out of the pool so we can reuse it. And the next one here is this profiling sample. So anything inside this block, we're going to profile, which is really handy. So when you go to the Unity profiler and you go to the timeline view, you'll get a colored block put in there. So when you're making your own effect and you're extending the pipeline, you can see how expensive your effect will be. And the way this works is when we use this command buffer and we say, please blit, please do all these different commands, all we're doing is we're queuing up commands that get executed later on. It's the same thing with the profile. We're not profiling this straight away. We're just injecting a start profile and an end profile command into our command buffer. So we get that profile in later on. So how do we actually then, we've got this render pass, how do we actually tell the lightweight render pipeline to use it? We have some interfaces we can override here. So here in this class we have I after opaque pass. So that means this get pass to enqueue function is going to get called after, to do something after all the opaque objects have been rendered. And it's up to us now to create our render pass in any data we need. We have access to the color buffer, the depth buffer, all the sorts of information. We can create a new object and pass that through and just return it. And we've achieved our goal here. We look at the frame debugger. We've now got my custom render pass in our frame debugger, executing different commands in the pipeline. And here's the various places you can inject a render pass in order of execution. You can do it after the opaque objects, after transparent, after render, after everything's been rendered. You could go and then capture the frame and do something with it. These are the various injection points. But this is all fairly abstract. I'm showing you some code and not showing you what you can do with it. Really what I'd like to do is give you some techniques here that you might want to apply. So the first example we're going to look at here is a refractive blur. So if you've done anything with command buffers before, you've probably seen this. This is the first command buffer example. When we released this, I know a few years ago, this was an example we gave. And so the effect we're going after here is this glass wall here, which it's see-through, it's blurry, it's got a bit of a normal map on it. So how would we achieve this effect? How would we do this? What we're going to do, the approach we're going to take, is I'm going to capture the color buffer. I'm going to capture, after I've rendered all the opaque objects, I'm going to capture that buffer that we have. I'm going to blur it, and then I'm going to apply it to this object. This wall here at the front, it's actually opaque. It looks transparent, but it's not. All it's got is it has a texture applied to it, which is the color buffer. So I'm going to render this wall. So after all the opaque objects have been rendered, I'm going to capture the background, I'm going to blur it, and then I'm going to render this wall here in the transparent queue and apply this texture to it. So let's look at the details of how that's done. So there's a few steps here. First one here is we just want to capture the color buffer. We want to get this information. So the line here, I just really want to, the main thing I want you to get out of this is that we're getting a temporary render texture and I can blit to it. I get access to the color handles, I get access to the depth handles. So just so you know what you have access to when you have a render pass, I can get any of the buffers and I can blit them and copy them. Again, I don't expect you to memorize all the commands here. It's just really get the principle of copying a buffer. And this is what it looks like. When I have that command buffer and I add a command to it, I start getting these graphics events turning up in the frame debugger. So here, this is what it looks like visually. My texture that's been passed in is the color texture from the camera. The render target. The render target is the one I just created called screen copy texture. So this is a render target I've just created. And the shader I'm using is a blit shader. It's a simple blit shader. So I'm taking the color buffer and I'm just blitting it to another buffer. And that's what this looks here like in the frame debugger. So now I have access to this screen copy texture and I can use that now further on in the pipeline. So the next thing I want to do is I want to start blurring this. So I don't want to blur this at full scale for performance reasons. I'm going to shrink this buffer down because as I'm blurring, that's an expensive operation. And when things are blurry, it doesn't necessarily matter if I'm blurring it, so it doesn't have to be a full-size crisp image. So first thing I do is I get some temporary render textures, temporary 1 and 2, and they're a quarter size of the full texture. And I again take another copy. I get the screen, this color buffer I've just captured, and just copy it to one of my temporary buffers. And the idea here is I'm just going to ping pong between these two buffers. I'm just going to keep blitting between them with a shader that does a blur. This is a separable blur filter. It doesn't really matter what the details are. So I've got a bunch of code here, but it's very repetitive. This is the ping pong in between. I'm just going blit, 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 blit from one texture to the other. And each time I blit, the shader that I'm using is going to start blurring the texture. This is what it looks like in the frame debugger. I'm rendering to temporary 1, I'm rendering from temporary 2, and I'm using my separable blur shader. And the final result is this. So I've got a quarter-sized buffer with all my objects in it, and it's blurry. So this is the second step. I've grabbed the color background, I've shrunk it down, I've run some blur shaders over it a few times, and now I've got a blurry color buffer. So this is really useful. This is going to be used in a lot of techniques. I'm going to use this later on as well. But this should show you just how you can capture things and start blitting them around. Finally, I want to apply the result of this. This is the final step. So this is just some parts from the shader that you can use. So the tag's at the top. So I'm putting this in the transparent queue. And this just means that even though this object's not transparent, it gets drawn after all my opaque objects. This is the trick I wanted to do, render all my opaque objects and render this one later. The next thing is the render pipeline. This is a new tag. So I'm just saying our render pipeline is a lightweight render pipeline. That's just kind of something you have to do here to use the render pipeline. And then the tag here is light mode, render lightweight forward. This is the default tag for a shader. I have a guide, actually, in the repository I'm going to show you at the end where I have all these samples. I have a guide for if you're a shader writer and you want to learn how to write shaders for the lightweight render pipeline. I have a guide there for kind of how you can convert between shaders you're doing now and shaders on lightweight render pipeline as well. So again, details are not important. I just want you to see this shader and see that here I'm getting the grab blur texture that I've blurred and I'm applying it to my object. And that's when we get our final result. That's the final result here. So far, I haven't really done anything that takes advantage of the lightweight render pipeline. All I've done is blit some textures. I've captured this image and blurred it and then reapplied it to another object. We could do this with command buffers. This is a command buffer sample. So I'm not really showing the benefits here, but it's a nice, simple example to start with. Let's move on to another sample now, which might explain things a little bit more. I'm going to do this per object blur or per object bloom, depending on how you look at it. So we can see that in these arrows and this light here, I've got this nice kind of glow effect. So this is something that's get asked for a lot. People want to just have something that glows. They don't want to blur or bloom the whole buffer. They just want to do it to certain objects. So how do we approach this? What I'm going to do in this situation is I'm going to tag all the objects that I want to have bloom on them in the scene. And then I'm going to draw all those objects as a mask to a texture. So I'm just going to render, I'm going to have a white texture, and all the objects that I want to have bloom on them, I'm just going to render them as black into this mask texture. And then I'm going to take that texture, and I'm going to use a post-processing effect. I'm going to use that mask to, again, capture the color buffer, but I'm going to capture things within the mask, and then I'm going to blur it again. You've seen how we blurred now. I'm going to blur it again, and then I apply it back on top. So that's the general technique we're going for here. I'm going to show you the steps for that now. So again, we've got some code to do this. The big difference here from what I showed you in the first example is in this example, well, the first example I just was blitting textures back and forwards. In this example, I actually have to do some drawing. I'm going to actually have to draw these objects into my stencil buffer. So I want to show you how you do that. The first step here is when I say register shader pass name. What I'm saying here is this pass is going to be interested in rendering these shader passes. In the shader I showed you before, I'll just quickly skip back to it. Remember how we said our light mode is lightweight forward? That's going to make sure that this shader gets rendered. That's going to be, the standard shader has this, any standard shader in lightweight render pipeline has this tag. So when I say register shader pass name, I'm just saying please render the default shaders in the shader part, in the lightweight render pipeline. You can make your own tags and do techniques with that. Next thing I do is I grab the stencil shader. This is an inbuilt shader that's in Unity already, the stencil write shader. This just will write black where an object exists. It doesn't do anything else, so it's a very simple, efficient, quick shader. And the last thing I want to do here is I want to say, okay, what objects do I want to render? I don't want to render all the objects. I only want to render the objects that are going to have this bloom applied to them. So I've got a few ways here I can filter. The first one here is I'm just saying, please render all the opaque objects. I'm going to do this for opaque objects, which is fine. And the second one here is a rendering layer mask. So there's two layers in Unity. There's the layer you find in the top right-hand corner where we can put things on different layers. And I can filter by that as well, by the way. But there's also a rendering layer mask. And this is just a number, and you can use it however you want. This is what it looks like in the editor. It's on a renderer, so any renderer has a rendering layer mask. And this is, when you drop that down, it's just 0 to whatever. It's a series of numbers. Because it's kind of hard to remember if you're setting up your scene, you're like, oh, the bloom layer, what layer was that? Was it 8? Was it 6? I can't remember. What I've done is I've created this helper script here per object bloom target. And what that does is it's a script that just runs all the time, or that just runs it and is going to set that number for you. So it just sets that mask. So if you're working with this, all you have to do is say, I want that object to have bloom. Okay, I'll just drag this script onto it, and it's going to put it on the right rendering layer for you. Okay, so we've marked some objects now that we'd like to render. Let's get to the setup now. So this is how I set up my mask buffer. So again, we're using render textures. So I grab a render texture, but I'm going to do some drawing operations now. So I need to set that render texture I've created as the current render texture. So when I set this now, it means anything I draw now is going to go into this render texture I've just asked for. I'm going to clear it to white, so this is going to be a white buffer, so I can render black objects onto it. Okay? And finally, this is the final step here, is now I can draw the objects. How do I draw the objects? First of all, I do have to do some setup. I have to set some rendering settings. I have to set up some camera settings. There's some helper functions to help you do this. So I'm just calling this create draw render settings. That's inbuilt, and it's just going to set things up for me. I can change things here if I want to. So I've asked for, opaque sorting here. I could put in a different sort order here. I could change camera matrices. I could do some VR mode special stuff here if I wanted to. This is a point here where I set up my camera data ready to render. The second step here is I set an override material. So that means everything in the scene now is going to be rendered with my stencil material, that one I created before. So anything I render now is just going to render black onto this buffer. And then the next step here is to draw. So I'm going to draw with the settings I've just set up. This includes my filtering, the filtering that's only going to render these render layers, so it's only going to render the opaque objects, all my filtering set up, all the setup. This is where it comes to the point where it's actually going to issue the draw calls to render those objects. And then the final line here is, now that I've got my stencil, I'm just going to set this as, make this available to shaders. So I just set this global texture and give it an ID. And that means now any shaders from here on in have access to this mask texture, and they can use it in whichever way they want. So it's a lot of code, but I think we get the main points here of setting up some filters, saying how we'd like to draw something with various settings, and then just drawing it. And this is what it looks like. I have a render target that I'm rendering to, the per object bloom. I'm using the stencil texture. And we can see that it's issued 2 draw calls. So this is fairly efficient. Because everything's using the same material, it's going to batch as much as it can. It's a very simple shader because it's just writing black. It doesn't have to do any lighting or anything like that. So this is a pretty fast and efficient thing to do. And this is the final result. So I've marked these objects. I've filtered on them. They've been drawn to this buffer. So I now have this buffer here, which is white background, black objects, ready to be used to mask out the objects I would like to put bloom onto. All right? So that's it for the render pass. From now on, I'm going to go to the post-processing. I've made this buffer available to me. So what I've got is I'm using the post-processing stack, version 2, and that lets you write your own custom post-processing effects. It's pretty great, and it's easy to use. I'll show you what it looks like first. So when I create, I override and create a post-processing effect, and I can actually create a user interface for it. So when I create some settings, they appear. So we can see here I have a post-processing volume with vignette and auto exposure, but I've also got my custom per object bloom sliders there, so I can change the bloom amounts and the bloom threshold, and the designer or whatever can start fiddling around with this. But I'll just show you the code. So this is the post-processing effect code. This is not the lightweight render pipeline code. But it's very similar to the first example I gave. What I'm going to do is I'm going to take a copy of the color buffer. I'm going to blur it. But when I take a copy of the color buffer, I'm just going to use the stencil. So I'm only going to copy over the parts that are stenciled. I'm going to blur the result, and then I'm going to add it back again. So again, the details aren't really important. This is really, we've got a series of blits here. When I say set up command buffer for the blit, that's just that ping pong back and forwards I showed you before. I just didn't show you that code before, where I go from temp 1 to temp 2, back to temp 1 to blur each step. And this is the result. So again, I've done it in a quarter size buffer just for performance reasons. I've got the objects in my mask, and they're blurry, which is great. And then what I do is I apply those back. So the one on the left is the rendering result without per object bloom. And when I do my bloom step, do my buffer, apply it back, you can see these nice glow effects around these objects. So I hope that shows you in those 2 examples the idea of the sorts of things you can do when you add in render passes to the rendering, to the lightweight render pipeline. I imagine people are going to start making these effects and putting them on the asset store. So you're not going to have to create this every time. You're just going to be able to say, download these render passes. Like I could put this on the asset store right now and have per object bloom, and all you'd have to do is drag the per object target onto objects and drag the pass onto the camera, and you're done. And for your studios, I imagine you'll start building up a bank of, if you're using the lightweight render pipeline, a bank of techniques you can use and reuse on different projects. So what I'd like to do is also talk about how you could replace the pipeline completely, or at least replace the rendering passes within it. And so why might you want to do this? Well, one reason is the lightweight rendering pipeline is a simple forward renderer. So what that means is it can take in up to 8 lights and do lighting in 1 pass. But once we get beyond that, there's already limitations to how many lights we could have. So if I wanted to have a game that had 100 dynamic lights that were flying around all over the place, I'd have to do something different. So I might implement a forward plus renderer or a deferred renderer, which what we do is we're going to render our objects to a geometry buffer first and then do lighting as a final stage. So you might want to implement something like that. You might be writing a 2D game. You might be writing a 2D game that has no transparent objects. So you don't want a transparent pass, you don't want all these other passes, but you do want a custom 2D lighting pass that happens. So in that case, you might want to, instead of taking the default render passes you get, queue up your own render passes. So you can still use the default passes that the lightweight render pipeline has. It's just up to me on how I'd like to queue them. So let's have a look at this deferred rendering example. I'm not going to show you the details of how it does the deferred rendering, but just how it sets it up. So I've implemented the iRenderer setup. And what this means is, hey, I'm going to tell you which passes to use. And then I have this setup function here. And in the setup function, I'm just saying in queue pass, that I'm enqueuing my deferred pass. So here I could, if I wanted to, queue up the built-in opaque pass. I could queue up, the built-in depth pass. I could do whichever I want, and then add my own custom ones in. But this is, you can get your own custom order and your own custom stack of how you're going to do things. There's a little more detail here on this deferred one, but I won't go into that. But this just shows you how you can make your own passes here. So if you're interested in doing this, there's some good resources you should go to. The first one here is from our Mexican evangelist, Arturo. He's just collected all these resources about the scriptable render pipeline in general, including the lightweight render pipeline. And this is links to the documentation, various GitHub repositories, and also Unite talks that have been given on this topic. So it's a great launching pad for you to find stuff. The second link is the GitHub repository of the examples I showed you today. So if you've wanted to dig further into those or use them on your own project, then by all means grab that. On this second link here as well, if you go to the wiki on that GitHub repository, that's where I have this shader guide. You should probably use the shader graph wherever possible because it's going to boil down to the rendering pipe you're going to use. But if you have to write your own custom shaders, there's a shader guide there that talks about those light mode tags, how the macros are different and the include files are different in the lightweight render pipeline, some clues there on how you can find things about lighting and that kind of stuff as well. So use that as a resource as well. But that's it. Thank you very much.